Good morning. It's warm and bright and sunny day here in Seattle, and I'm not kidding. Let's get started. So, why best practices? Best practices are cool. Lots of people will listen to you if you talk about best practices. So they actually they can help you save money, save some time, and more importantly, a lot of frustration. So we're first going to talk about best practices for high performance with Amazon RDS. So scaling database performance with RDS is fairly painless and straightforward. There are multiple dimensions through which you can scale your database performance independently. So you can scale your CPU separately from your IOPS. You can increase your storage, decrease your storage, independent of the CPU or memory configuration of your database instance. And so this is especially useful for a couple of use cases. So if you are starting an application from scratch, and you can start with a smaller instance. As the demand for your application grows, you can scale up your storage, you can scale up your instance size and IOPS as well. Again, all independently, depending upon which dimension your workload is constrained on. And this is also especially useful for production instance cloning. So if you're creating development or test environments, you may want to create them with lesser CPU, lower amount of IOPS, etc., to save costs. Another dimension through which you can scale database performance in RDS is through using read replicas. So if you're using a production application, you would definitely want to use multi-user deployments for high availability. And as the read, if you have read traffic, a lot of read traffic on your database instance, and you want to move that traffic to a different instance, so you can do that with RDS through read replicas. And so there are a lot of our customers who want to use read replicas for BI and reporting purposes and not strain their production database instance with read traffic. And so that is one other use case. And so you should still serve your write traffic through the master instance, and you can create a read replica which establishes asynchronous replication using MySQL native technology, and which means the replica can lag behind the primary instance by a few seconds. And so you can serve your eventually consistent, you can serve your traffic, read traffic through the read replicas, which has eventually consistent reads. So you can create multiple replicas and serve more read traffic through that. So this is a high-level overview of how you can scale database performance with RDS. So I'm going to focus a lot more today on provisional IOPS storage. So we talked a little bit about IOPS being one dimension through which you can scale your database performance. So provisional IOPS storage is introduced about 8 or so months ago on RDS. It's fast, and it's a storage that provides fast and predictable performance. And if there is one takeaway that I want you guys to go away with from this presentation, it is the following. The first best practice for high performance with RDS is to use provisional IOPS. And so we support up to 3 terabytes and 30,000 IOPS for RDS per database instance. It varies by database engine. We're going to talk about MySQL shortly. And with RDS, you don't have to worry about creating EBS volumes, attaching to an EC2 instance, striping the storage for better performance, etc., etc. So all that is taken care of by the service. So when you create a database instance, all you're going to specify is, hey, I need X amount of storage, Y amount of IOPS, and Everything else gets done behind the scenes in terms of storage management and striping, etc., to give you that level of performance. So there are a few things you would want to understand about provisional IOPS, especially related to disk metrics. So IOPS is, of course, the first thing that you would want to learn more about. It's number of I/O operations per second, latency for I/O. So it's the time between the submission of an I/O to its completion, and throughput as well as QDAP. QDAP is the number of outstanding I/Os waiting to be serviced. So these are metrics that are shown to you via CloudWatch, which is our monitoring system, when you use RDS. So we're going to talk a little bit more about these metrics shortly. So if you, with 1 millisecond latency, if an application is using one thread, the most that you can get with 1 millisecond latency with one thread is 1,000 IOPS. You cannot, even if you get a larger box, you won't be able to serve more than 1,000 IOPS. So the way to increase the number of I/O is to use more threads. So that is where concurrency comes into the picture. So we have seen a lot of customers provision up to 10,000 IOPS and not able to realize that many IOPS, plainly because they use fewer threads. So here is an example that one of my colleagues put together that we're going to talk about briefly to kind of understand a little bit more about concurrency as well as latency. So as you can see here, there's a CloudWatch graph, and this is an instance corresponding to an instance with 3,000 provision IOPS. And with one thread, we are able to realize close to 700 IOPS. It's not technically 1,000 IOPS, but it's just very close to that. Probably there's some caching going on. So this is all read IOPS. And with 4 threads, we are able to get to about 2,250-ish IOPS. And so as I mentioned before, the instance is provisioned with 3,000 IOPS. We're getting fairly close to 3,000 there with 4 threads. And with 16 threads, you're able to saturate the number of IOPS you provision. So you're getting close, actually, roughly around 3,000 IOPS with 16 threads. So the flip side of this is to look at the latency. And so you can see with one thread, you're able to get to sub-millisecond latency, which is fairly close to what you can get with SSDs. And with 4 threads, you're able to realize the same level of IOPS. But with 16 threads, you can see that the latency increases substantially by about 4 to 5 times. And so the question here would be, why is there a degradation in the latency metric? And so as we talked about shortly before, with 4 threads, we are already pushing close to the amount of I/O that you can get from this instance. With 16 threads, you're pushing a lot more concurrent I/O. So what happens here is, since the capacity of the system is 3,000 IOPS, the rest of the I/Os that are concurrently generated gets queued up, and which increases the overall latency of the system.
You might want to mention that we'll take a lot of questions are piling up. You might want to mention we'll take questions when you're ready.
Yeah, so we'll take questions at the end of the presentation, so that we can go over them. So with 16 threads, like I was mentioning, we have I/O queuing up, and that is essentially leading to more latency. And so this is a queue here to increase the number of provisioned IOPS for the system, and then that will subsequently impact the overall latency. Okay, so we talked a little bit about QDAP, and so this is a metric that we expose through CloudWatch. And so the rule of thumb is you should maintain a QDAP of 5 for every 1,000 IOPS, 5 outstanding I/O requests for every 1,000 IOPS provisioned. So if you don't see that kind of a QDAP, it's very likely that one of the reasons could be your application is actually not generating enough I/O. And if you see more than 5 outstanding I/Os per 1,000 IOPS, as we have seen in the previous example, so it's very likely that you are I/O constrained and you would want to increase the number of IOPS. A few other things to consider with provisioned IOPS. So the second best practice is use provisioned IOPS optimized instances. You don't want to use provisioned IOPS with a micro instance. It simply doesn't have enough capacity in terms of bandwidth or CPU, etc., to be able to push the kind of I/O that we support with provisioned IOPS. So minimum number of IOPS that you can provision with RDS is 1,000. And you can go all the way to 30,000 as we spoke about shortly before. So we have a subset of Amazon RDS instance types that are provisioned IOPS optimized. These include M1 large, extra large, 2 extra large, 4 extra large, up to 8 extra large. And so M1 large supports 500 megabits per second, and M24XL supports 1,000 megabits per second in terms of channel bandwidth. This is the bandwidth that is available, in a dedicated manner from EC2 to EBS. And so you want to have dedicated bandwidth to be able to realize the I/O and the latency profile that we have designed the system for. And so there are a few things that you want to keep in mind when you look at channel bandwidth. So this bandwidth is full duplex, which means you have the same amount of capacity available for read traffic as well as write traffic. So you have, for an M24XL instance, you have 1,000 megabits per second available for reads and 1,000 available for writes. And so 1,000 megabits per second translates to roughly 100 megabytes per second, including protocol overhead. And 100 megabytes per second translates to about 6,250 16 KB IOPS. So with an M24XL instance that has 1,000 Mbps, the maximum realizable IOPS for reads is 6250 theoretically, and the same number for writes. So for workload which has 50% reads and 50% writes, so uniformly distributed workload and not lopsided, the maximum realizable IOPS is 12,500 for an M24XL instance. For a similar type of workload, CR1-8XL, you'll be able to realize a lot more, up to 20,000 IOPS. So these are theoretical values. The number of IOPS that you realize is going to be heavily dependent on the workload. We'll talk a little bit more about what sort of factors determine the amount of IOPS that you're able to realize. And so in the beginning, we talked about RDS supporting up to 30,000 IOPS per database instance. So even though 20,000 is the maximum realizable IOPS for a MySQL instance on CR1-8XL, provisioning more than 20,000 could help you with reduced latency. So in some of the benchmarks that we did, increasing the number of IOPS beyond 20,000 helped us increase the overall transaction rate for the system by 10 to 15%. So that's something that is going to be dependent on workload, and you might want to understand whether going beyond 20,000 for a CR1-8XL or 12,500 for an M24XL is helping you reduce your latency for your workload. And the next thing that you'll want to think about for provisioned IOPS is the size of I/O. So EBS, from an EBS perspective, any I/O size less than 16 KB is counted as one I/O. And if you have more than 16 KB, it is counted as multiple I/Os. For example, a 32 KB I/O is equivalent to two IOs. So 6250 16 KB IOPS that we talked about will be equivalent to half of 32 KB IOPS. So if you have blogs, etc., that you are reading, the number of IOPS the overall amount of IOPS need to be adjusted accordingly from an expectation perspective. Okay, a few other things to consider when using Provisional IOPS. So a lot of questions that we come across from customers, hey, I provisioned these many IOPS, but I'm not able to realize. And so we talked about that being workload dependent. So in the first example, we looked at the number of threads. So if you have fewer number of threads, it's likely you're not going to realize the number of IOPS that you provisioned for the system. If you're not using provisioned IOPS optimized instances, again, there's a likelihood that you won't be able to realize the IOPS that you provisioned. And another thing to keep in mind is there are a bunch of background processes related to database management. For example, automated backups, snapshots, scaling storage, etc. So all these operations consume I/O. And so if you are not able to realize the specified number of IOPS, you might want to look at if there are these processes running at the same time. And reviewing QDAP is important. You want to look at how many outstanding IOs you have, and maybe it's likely that your application is actually not pushing enough IO. So that could be one of the reasons. And the last thing, which is very important, is database contention. So depending upon the nature of your workload, it's possible that you might be running into lock contention issues or deadlocks, etc., and those will impede your ability to realize the amount of I/O that you provision for the instance. And let's talk about a few more things that could help you with better performance with databases. And one of the things that we often see customers running into is connection-related issues, and too many connections is an error that a lot of MySQL customers run into. And the first thing that we have seen customers doing is and this is dictated by the MySQL parameters. So there's a default value that RDS sets for parameter groups, and so that determines the number of connections that you would be able to realize depending upon the instance type. So all of this is dependent on the memory. So given that each instance type has different levels of memory, they have different levels of maximum connections that they can support. And so if you look at the parameter group for max connections, you'll see a formula there through which you can derive how many connections by default are going to be supported for a given instance type. And if you run into, if you're trying to have more connections than the max configuration, you'll likely run into MySQL errors. And so we have seen a lot of customers going and creating a custom parameter group and actually, upping the number of max connections. But this leads to other issues if, not thought through carefully. So you have to look at max connections in conjunction with the overall memory available and the memory that is configured for InnoDB buffer pool size. If you're increasing the number of connections, you might want to decrease the overall memory allocated for InnoDB buffer pool. Otherwise, there is a likelihood that you'll run into swapping and performance issues. And so this is especially interesting for larger instance types that have a lot of memory, and if your database instance is small enough, for example, if you take an M24XL or CR18XL for that matter, you have 250 gigs of RAM available, and if your working set or the database instance size is 50 to 100 gigs, it could all fit into memory. And if your application has a lot of concurrency requirements and you want to create a lot more connections, you can do that by decreasing the amount of memory allocated for the InnoDB buffer pool size. Well, that's a tongue twister. So the next thing you want to think about is connection pooling. So a lot of application servers have connection pooling built in by default. So it's tricky with PHP. There's no direct way to do connection pooling. So if you're using PHP, so it's very likely that you're just going to create new connections for your requests. And there's likely no possibility to do connection pooling there. One of the things that you can think about is, apart from of course using a different language, is if your workload has high connection rate, it spawns threads, and you can think about looking at the threads created and increasing the thread cache parameter so that threads at least are cached and you're not spawning a lot of threads which might consume CPU capacity. The next thing to consider, so we talked a little bit about scaling database performance through read replicas, especially for the applications that have more read to write ratio. And so as many of you know, MySQL replication is single-threaded. It's a bit brittle. With 5.1 and 5.5, there is a likelihood that replication may stop after crash recovery on the master. And so with multi-AZ deployments, when a failover occurs, it includes a crash recovery. So there is a likelihood that you will see your replicas stop replicating after multi-AZ failover. So one of the reasons for that is, the primary reason for that is sync bin log is by default set as 0 with 5.1 and 5.5 on RDS and MySQL as well. And so that means logs could be written without flushing to the disk, and those could be transferred to the slave before they get flushed to the disk on the master. And if there is a failover that happens before the flush action is complete, there might be a log record mismatch between the slave and the master. And one of the things that you can do is make sync bin log as 1, but we have seen a lot of performance impact when doing so with 5.1 and 5.5. So you might want to test it for your application and see how what kind of penalty you're incurring. One of the other things that you could do is use a stored procedure that we introduced called RDS next master log. And using that, we'll skip the log from the troubled one that has mismatch to the next one, and so that the log application process continues. And so this, of course, is a strong caveat here. There is a potential, there's a high likelihood that you're going to miss some writes that are made to the master using this approach because you're actually skipping a log. But if your application can tolerate such mismatch, such missing information, so that is one of the options that you might want to look at. The other thing that you would want to know about is MySQL 5.6. So it has what is called as crash save slaves. So with MySQL 5.6, RDS sets the sync bin log parameter as 1. Which preempts this issue from happening. This, of course, does have performance penalty as well, but we believe it's not as much as it is in 5.1 and 5.5. But doing so increases the reliability of your read replica substantially. So if you are not using 5.6, we encourage you to try it out and understand the read replica behavior, and use it subsequently. The next topic, not necessarily tied to performance, but something that you should keep in mind. By default, when you create a database instance with RDS, backups are turned on. So backup retention period is set to 1. And please do not turn backups off until you know what you're doing. So we're going to talk a little bit about data import, and so there are cases where you might want to turn off the backups before batch loads, etc. But for all other practical purposes, please ensure that you have backups turned on for your production instances. So what that means is whenever you have a backup retention period, say for example if you set it for 8 days, RDS takes a nightly backup during your maintenance window, and that is a snapshot, database snapshot. And in addition, depending on the retention period you set, RDS backs up the transaction logs associated with your instances to S3, and at a 5-minute interval. So this is a very useful feature for disaster recovery. Or oops, somebody deleted my table, but I haven't noticed until, long time later. So these are cases where you might want to use point-in-time recovery to retrieve, the data. And what a point-in-time recovery entails is, if you have a backup retention period of 8 days, the last 8 days, your transaction logs are all backed up at 5-minute intervals. And so if you're trying to restore your database instance using this method to a specific point in time in the past, what RDS does is we look at the latest backup available prior to that point in time, and we roll forward all the transaction logs that have been backed up. And so this is a very time-consuming process. Log application is single-threaded as well. And so depending upon the transaction rate and the amount of data that has been written, this could take several hours. But like I said, it's an extremely useful feature for disaster recovery purposes. So other thing to keep in mind is if you want to clone your production database instances to create staging or dev test environments, you don't want to use point-in-time recovery. You rather would want to use snapshots. So create a snapshot of your production instance and restore from the snapshot. It's a much quicker process to clone database instances. And a few other best practices here, a bunch of, probably not very related ones to performance, but things that we see customers running into often. So from a storage engine perspective, RDS by default has InnoDB storage engine. We do support tables with MyISAM, but please avoid using MyISAM if you can. It is not transactional. There are lots of issues that you could run into if you use MyISAM. For example, point-in-time recovery, for one, may not work because of the non-transactional nature of MyISAM. There is also a strong likelihood that read replicas may not work and could break more often than they would with InnoDB. The second thing to keep in mind is CloudWatch alarms. So it's an extremely useful feature, but not as well adapted as we would like to. So for example, you can set CloudWatch alarms on a variety of metrics that RDS exposes, including CPU utilization, memory, storage usage, latency, read latency, write latency, and replica lag. So if you have, it would be, we encourage you to set up CloudWatch alarms. For example, CPU utilization is above 90% for, 3 subsequent 60-second periods. So that is a CloudWatch alarm that you would want to set, and so that you proactively look at such cases and understand, what you can do. Maybe you might want to scale up the instance. Otherwise, there may be severe performance degradation. The same thing with storage usage as well. So with RDS, it's extremely easy to scale storage, and it's an online operation, meaning if you're scaling storage from X gigs to Y gigs, it all happens behind the scenes. Lots of data get moved between volumes, but your database remains up. So there may be some performance penalty. But while it's extremely easy, if you don't proactively monitor your storage usage and you run into a storage full state, which means you provision 100 gigs and you actually consume 100 gigs, the MySQL process crashes and wouldn't start until you take more actions such as deleting data, etc. So it's a precarious situation to be in, and being able to define CloudWatch alarms for storage is going to be extremely useful. The same with replica lag as well. If you have applications that are not tolerant to long replica lags, you might want to set an alarm and ensure that the lag is at tolerable levels. The third thing that I wanted to briefly bring up is SMS email notifications for a variety of database events. It's again an extremely useful feature. We launched it in January. Very, very useful where you want to monitor database specific events. For example, failover. So if your production instance, multi-agent instance fails over, you can set up notifications to ensure that you're notified when such an event happens. The same thing with replication status. So if the thing that we talked about, if there is multi-AZ failover or if there are other transactional issues, given the limitations of read replicas and MySQL native replication, so you might run into cases where replication breaks and MySQL runs into errors. And so replication status is a very simple way to monitor whether your replicas are still replicating. And setting up notification corresponding to that event will help you quickly understand if there are replication issues and deal with them as appropriate. The last thing on the best practices for performance, not again necessarily performance here, but availability. So keep in mind, if you use a ton of tables on MySQL, that's going to extremely slow down the crash recovery process. So the failover typically takes a few minutes, anywhere between 3+ minutes on RDS with multi-AZ instances. If you have with manageable number of tables, if you end up creating tens and thousands of tables, this is going to take a fairly long time, and we have seen cases where customers end up having their database down for several hours because they have millions of tables. Not something that most customers do, but please keep that in mind.
To that point, I see a few questions about the thousands of tables. One of the other ways to mitigate that is we have file per table enabled, and so the file per table causes crash recovery to take a long time. If your application calls for thousands of tables, the best practice is to disable file per table so that you don't have tens of thousands or even hundreds of thousands of individual tables that need recovery.
Yeah. So MySQL reads every file when a crash recovery is performed. So with that parameter set, each table corresponds to a file, and that's why it just takes a fairly long time. So please keep this in mind. With Provisional IOPS, the crash recovery process is much quicker, and that's why you can have more tables as well if you're using Provisional IOPS. So that is what I have from a performance perspective and some best practices. So I'm going to turn it over to Shakil to go over best practices for data migration.
Thanks, Pawan. So let's talk about data migration in the next section. So there's a few best practices that we want to talk about, and depending on how you're doing the data migration, we can discuss which ones would be applicable and the process to go about doing the migration itself, right? The first thing is, before you do a major migration or a data import, you want to prepare the instance, and you can do a few things to prepare the instance within RDS that you are importing into. Pawan mentioned the fact that you can enable or disable backups. That essentially impacts whether or not bin logs are being turned on or off. So in preparation of importing large amounts of data to an RDS instance, you do want to turn off backups, and that's the one case where you do want backups turned off, because that will help do a data load quickly. Other things you want to keep in mind is if there are any applications accessing that database into which you're importing any data, you should stop those applications from accessing the database, because that's just going to burden the database, which isn't really contributing to your load performance. You should also take snapshots before and after the migration, which would be just common best practice anyway. Now, there's two aspects to doing a migration. You could call them either a basic migration or an advanced migration, but essentially what we're talking about is if it's a one-off dump and restore, that's what you'd call a basic migration. You either use a MySQL dump utility or extract data out of the source database and physically move it to somewhere near AWS, either on a staging instance in EC2 or somewhere, so you have the dump file available, and then use the MySQL utility to import the data into an RDS instance. If you were using flat files or other types of data, you could use the MySQL import and import that data into RDS. So those would basically work, and once that database is available, ready to be used, you want to turn on backups, you want to put it in the right configuration, whether it's multi-AZ or set up read replicas, and then point your applications to this database, and you're off and running. And basically, that's the basic type of migration that you can talk about. But this is usually not sufficient for people. This is good when you have a lot of time to do a cutover and you can take downtime in between the migration. The question is, what happens if you want near zero downtime migration? You want to minimize the downtime between the source database and the target database being turned on. So this is where stage 2 would come in. Essentially, you still need to do the first phase where you take a dump and load it up into an RDS instance. But besides that, you can also now, with MySQL 5.6, actually with 5.5 as well as 5.6, you can set up an RDS instance as a target, as a slave of an external database. The external database could be on EC2, could be anywhere else. So this would allow you to do the replication, which will catch up all the changes that have happened on the source database while you were doing the migration, right? So essentially, let's talk about what all is involved in this case. First of all, you've got to prepare your RDS target. You've got to make sure it's running the right version of MySQL. It needs to be either 5.5.33 or 5.6.1.3. If it's already got data, you want to take a snapshot on that RDS target. You want to choose the right instance class to make sure your load performance is going to be appropriate. Figure out if you need PIOPS or not. Make sure it's got the right parameters set in the parameter groups. You would need to set up some security-related rules, specifically because you're using an RDS instance as a slave, as a target of an external database. You want to make sure that traffic is allowed. That same concern happens to be on the source side as well. If it's like a database sitting in your corporate data center, you might need to open up some firewalls, some ports somewhere to allow that traffic to happen. The other things you want to do on the RDS target is if it's running multi-AZ or has read replicas or applications connected, you want to disable all that just to improve your load performance. On the source side, again, you want to make sure it's configured to be a master, right? So bin logs are turned on, for instance, and so on. Now, the real magic of turning on an RDS instance as a slave, as a replica, happens to be done by a couple of stored procedures that we provide. They're called MySQL.RDS set external master procedure. That's what you use to turn on replication to set up an RDS instance as a slave. And once it's replicating, you want to monitor that replication, make sure the lag is tolerable, acceptable, and then once you are certain that both the databases are synchronized, they have all the data that you need, at that point you call another stored procedure, which is called the RDS stop replication procedure, and that would break replication, at which point the RDS instance becomes a master. You can repoint your applications to that RDS instance and continue processing. So this would be what we would advocate as the best available minimum downtime migration mechanism for MySQL with RDS today. Once all this is done, obviously you want to take a snapshot on the RDS instance. You want to enable backups again. This is a very critical thing because you disable them only so that replication and load performance was appropriate. Once all that is done, you want to enable your backups. You want to go back and relook at your security configuration, remove any extraneous rules that you had inserted just to set up replication. Make sure if you need multi-AZ, if you need other replicas, all those are brought back in again. So those would essentially be the steps in addition to doing the replication, but that would cover the best practices around advanced zero downtime or near zero downtime migrations with RDS. So we covered all this, plus also make sure you're turning on any monitoring, right? So you want to set up CloudWatch alarms, make sure you're monitoring CPU, definitely monitor and set threshold alarms for storage. This is a critical issue. Many customers run into this where once the database is run out of all available storage, recovering becomes a little bit of a challenge, but make sure you're getting notified so that you can intervene in time and expand storage. There was a question about this as well before, but essentially you can add storage to an RDS instance, either MySQL or Oracle, on the fly. You do not take downtime for that. You can go up to 3 terabytes from any smaller amount, and without any downtime, online you can add more storage. Okay, so the final topic we're going to cover today is the new MySQL 5.6 features that have become available and are also available with RDS. Again, this is not meant to be a tutorial on MySQL. We're just briefly mentioning these features so that you're aware what is possible with RDS using MySQL 5.6. So the major improvements, Pawan already talked about this a little while ago. It has crash save slaves, but in addition, there's a lot of read replica related improvements, right? So crash save slaves would be where you can automatically recover from failure and resume your DML updates. You don't have to roll back transactions or to go back to the last committed or to skip transactions manually. All that kind of stuff can be avoided for the most part, so that's a huge improvement. The MySQL servers are multi-threaded, right? And that helps a lot because if you've got one replica receiving changes from multiple databases, you could have one thread for each of those replication sources, and that allows you to update in parallel and improves replica performance. So huge improvement there as well. MySQL 5.6 uses checksums now for replication, both on the bin log and as well as on the replication events itself. So you're not creating corruption in the slave because of replication issues. So that's another major improvement. You can set up time delays. So all these are possible, and obviously with MySQL on RDS, you can monitor the performance of the slave, monitor for replica lag, and make sure your replicas are healthy. If you need to, you can drop previous replicas and start new ones. So major improvements there, like I said. Another big improvement is the availability of the Memcache daemon essentially running within the same server as the MySQL server, right? This is big. This can improve performance in many different ways. From the basic stuff, right? When you send a request for data into MySQL over Memcache, the server doesn't have to go through parsing and planning for SQL and so on. So there's just basic raw performance improvement. The Memcache daemon is running within the same process as the MySQL server, so it doesn't have to do network hops. So you save on all the performance and the latency hits that you would get otherwise if you were using a separate cache. Think of it as a persistent cache, right? When you write, you make changes to the cache, they're automatically written to disk. You don't have to worry about, okay, now I made a change to cache, I need to go do an update somewhere. Or even when starting up, you don't have to warm up your cache. You can directly start accessing it as Memcache, and then if the data is not in memory, it'll be brought up from the database and cached. And all this memory management is being done by MySQL. Basically, it's using the NODB buffer pool. So you don't have to do any separate planning for cache memory and so on. With multi-AZ RDS, you can get this cache available in high availability and failover as well, right? So if your cache and your MySQL server dies on one place, it comes up somewhere else. The cache might not be completely warm, but then, like I said, you don't have to warm it up yourself. You can access objects, and as they're accessed, they become available through the cache. So lots of improvements that are possible. Depending on the nature of your application and how you access data, you could see huge performance gains there. And another improvement here is you don't have to access the database just as a database, right? With Memcache API, you could be accessing it over C, C++, Java, Python. Your choices of accessing data are increasing because you are using Memcache here. Other improvements with MySQL 5.6, you have access to bin log, and not only do you have access to the bin log, you have access to the bin log on RDS instances as well. So this is new. We did not provide you access to bin logs prior to MySQL 5.6, but with 5.6 you do have access. Well, the first thing is you have to have backup retention enabled because, like I said, that's what creates the bin logs in the first place. Then you use the MySQL bin log tool, and you can either download your bin logs or you can stream them. Essentially, you use a stop never type parameter to keep streaming from your host machine onto wherever else you are, right? You could be on an EC2 instance or a remote machine somewhere. And once you have that bin log, you can use it for anything, right? You could be replaying all those transactions using the MySQL utility and pushing them into a totally different database if you like. So big changes from the way you've dealt with RDS in the past and huge improvements in access to data either for export or even for ongoing replay against a separate database. Other improvements with 5.6, you have the ability to do online DDL now, so without taking downtime, you could be adding columns, you could create indexes, so your availability improves, your flexibility to modify your applications while keeping your end users working against the database improves a lot. So had been a major ask for MySQL customers for the longest time, and obviously 5.6 now provides it. Other things, if you use any kind of searching within the database, 5.6 now offers full text searches. You can do natural language searches if you like. So just better improved usability and enhanced performance and usability features for 5.6. So all these are again available with RDS as well. And if 5.6 is an option for your applications, we would encourage that you migrate at some point to 5.6. So that's all the prepared content that we had. If there have been questions so far, we'll now go through those in the available time. We've got maybe 10 minutes or so left. We'll use those to go over your time, to go over your questions.
Yes. So we have a ton of questions here. We'll try to answer as many of them in the time frame available, and we'll follow up for the rest of the questions. Okay. So I'm going to pick a few questions. So there are a few questions around whether the slides are going to be available, etc. Yes, we're going to make it available and have the recording of the presentation available as well. And there are a couple of questions around 5.5 to 5.6 migration. What are the best practices to migrate from 5.5 to 5.6 with minimal downtime, etc. So today we support in-place upgrades from 5.1 to 5.5. So we don't support 5.5 to 5.6 upgrades in place. And we are working on supporting that. And one of the things, it's not supported again right now, but we'll make it available in the next few months. So creating a replica with 5.6, having a master as 5.1 or 5.5 instance, and being able to promote 5.6 instance would be one way to do it. Again, not supported right now, but please stay tuned. A couple of other questions. Best practices or options for just-in-case rollback contingency for RDS back to source. How to bridge the data discrepancy of data written to RDS and not source after migration goes live. Phil, do you want to address that? So how to bridge data discrepancy after data migration to ensure that there are no transactions written onto the source and not propagated to RDS.
I'm not sure I completely understand the question. I mean, when you do a cutover, you have to have at some point you need to stop writes to the source application.
Yeah.
And there's obviously an outage to reconfigure your application to address the new instance. And so there's nothing that RDS can do to manage that for you. Basically it's basically it needs to be managed at the application layer. So you have to take an outage, perform the cutover, and in that time, you can observe the replica lag. And when you've stopped writes, when the replica lag is current, then you know that those writes didn't happen. It's the kind of thing that in a production environment you need to rehearse in a non-production environment so you can develop the proper technique.
Makes sense. Okay. The next question we have: if you don't recommend more than 1,000 tables, does that mean that there are issues and partitioning is used to increase the table number?
No. So as I interjected before, that we see a common problem with instances that have tens of thousands of tables, in that when they do a reboot or they do a failover, crash recovery can take a very long time. So the solution to that is to have designs that don't use a lot of tables, or to use not use file per table, which doesn't suffer from this. In addition, as we mentioned in the slide, PIOPS can help because it's a very I/O intensive operation doing crash recovery. So that's about it. It's just understanding. And another thing is you have to turn off file per table before you create your 1,000 tables. Otherwise, you need to do some sort of conversion. So that's just a good best practice. We see that a lot with for example, customers who use WordPress, that's an application that creates a very high number of tables, and so the recommendation there is not to use file per table.
Okay. What are the best practices for backing up RDS? We use the auto snapshots, but it's terrifying that those are deleted if the DB is ever deleted. Is a manual snapshot persistent, or should we manually be doing export stress 3? So I can take that up. Manual snapshots persist, through until you go ahead and explicitly delete them. Whereas the system snapshots that are related to the automated backups, those get deleted if you delete an instance. We do have an option when you delete an instance that asks for whether you want to create a final snapshot. If you say yes, there's a snapshot that gets created before the deletion happens. But manual snapshots do not get deleted until you explicitly delete them. The next question we have here is, can RDS instance itself redirect the read queries to read replicas? No. This is something that you have to manage at the application level. Next question, if we modify an RDS instance, multi-AZ in my case, does enabling or altering provisioned IOPS affect uptime while modification is taking place? So I think there are two questions here. So the first one is about enabling provisioned IOPS for a standard storage multi-AZ instance. And so for this, when you initiate a modify operation and say use provisioned IOPS for my multi-AZ instance, there is a downtime impact because we perform a failover to ensure that you get a provisioned IOPS optimized instance. The standard storage instances are not provisioned IOPS optimized. So that happens on the on the standby first, and then we initiate a failover. So the amount of downtime that you incur is bounded by the amount of time it takes for the failover, which is typically 3 minutes. And after the failover is complete, we perform the conversion process behind the scenes. So it could take several hours for the conversion process to complete, but your database will be online and you'll be able to access it. Of course, there might be some performance impact as well because you're going to move bits across volumes.
The important thing to keep in mind there is there is an outage only when converting from standard storage to PIOPS. Once you're on PIOPS, any modification to the storage, whether you're increasing the size of the volume or modifying the number of IOPS, that is a completely online operation.
Okay. The next question we have here, the bandwidth figures, were they for disk access only, or is it shared with network activity? It is for disk access only. It's a dedicated bandwidth between EC2 and EBS. Okay. For point-in-time recovery, do queries get logged by default, or is there any switch to turn the sort of logging on or off? So point-in-time recovery, like I described, is tied to the backup retention setting. So if you have a backup retention of, the period that we support is 1 to 35 days, and you can set this to any value you like. And for that period, for the trailing period, corresponding to that selection, the transaction logs gets backed up, and you can perform a recovery to any point in time within that retention period. Okay, so a couple of questions here on MyISAM and InnoDB. I know you can mix MyISAM and InnoDB on a single RDS instance. Do you lose the backup functionality if you do so? Phil, do you want to take that up?
No, backups and point-in-time recovery work just as they do regardless of the storage engine. The caveat is that because MyISAM is non-transactional, you have less success in point-in-time recovery. So just as if it's non-transactional, it's by definition not crash recoverable. And so it works, but we can't guarantee that it will roll all the way through. So that's the main reason we recommend InnoDB in cases where you want to rely on features such as point-in-time recovery. If you simply need to use if you want MyISAM because it's fast, and you're only going to ever use restore from snapshots, you'll probably be okay. But you always have the potential for data loss because there's no guarantee in the non-transactional engine.
Another related question. I use MySQL for better performance and faster queries. Transactions aren't all that important for my implementation. Should I switch to InnoDB anyway?
So we sort of just answered that question. We take a very high bar when it comes to data loss, and so if you can tolerate data loss, then you can run MySQL. We sort of don't recommend that because the ultimate goal is to have zero data loss and be able to always support point-in-time recovery.
Okay. So is multi-AZ failover supported in 5.6? Yes, it is. And let me see a bunch of other questions that came in.
So meanwhile, just to let everyone know, yes, we'll have the slides and the recording available from the same website at the end of the session. So any questions along those lines, yes, we will make all the stuff available.
So next question, so we have a couple of minutes left, so we'll pick two to three questions. If I make my AWS read replicas, sorry, the question just went up. Okay, if I make AWS read replica writable and then add tables to the read replica, will it replicate to the master? So replication is unidirectional. It goes from the master to the slave. So if you do add new tables in the replica, they don't get replicated back to the master. But one thing to keep in mind, if you are doing any writes on the read replica that might conflict with the replication that is happening from the master, the replication could break and stop. So that is something that you should keep in mind. What is the recommended way to disable bin logs for a single database restore? I don't understand that question, but if you want to disable bin logs, you have to go and change the backup retention to 0. Why can't I have an on-premise MySQL replicate all the time to MySQL RDS? So we do support non-RDS to RDS replication, so that is one of the ways we recommend through which you import data to RDS. But like we discussed, replication is brittle, MySQL native replication, so you have to take the responsibility to ensure that replication is ongoing if you want to actually rely on it.
Yeah, but I think the question is they can keep you can keep it in a replicated state indefinitely.
Yeah, as long as you take the responsibility to maintain the replication. Okay. What do you mean by replication from an instance of MySQL that is not running under Amazon RDS is only supported during the time it takes to transfer a database to an instance of MySQL that is running under Amazon RDS? So I don't know if... I
think it's the same question.
Yeah,
essentially,
the same question.
We are not preventing you from doing ongoing replication if that's what you want. All we're saying is it might not be such a good idea because native MySQL replication can break, and so relying on that as a mechanism, let's say for DR or something, is up to you to decide. That's all we're saying. We're not saying you cannot do it.
Okay, a couple of other questions around backups. Best practices for taking backups without disturbing application availability or connection timeouts. So a couple of aspects here. So if you're when we perform backups, we take a snapshot, and given that we have striped data set, we have to freeze I/O, and this process usually takes a few seconds, and then the snapshot gets initiated and happens in the background. For single AZ instances, this means that this will manifest in higher write latency or read latency for that matter during the time the I/O freeze is in place. For multi-AZ instances, we do take the backups from the standby instance, so you don't have the I/O freeze-related penalty. But at the same time, given that the snapshot process occurs in the background, there is likelihood of increased latency for multi-AZ instances as well during backups. What is the best practice in creating, so last question, what is the best practice in creating auto-scaling read replicas? So we don't support that functionality natively like we discussed shortly a while ago. There are third-party tools out there that do support distributing traffic across multiple read replicas using RDS. Recommend to look at third-party tools and figure out which of them are appropriate for your use case. That's all we have for today. There are a bunch of other questions. Please feel free to post questions on the forums. We monitor them very actively and we'll respond. And for the rest of the questions, we'll